Okay, so our review P stands for preview. It's our review 1. It's before we get into the calculus stuff to remind us of things we should know. We are going to, you don't have to write down the objectives, but we are going to sketch graphs, find intercepts, test for symmetry, find points of intersection, and interpret mathematical models and real-life data. So this is just their slides, so I may be skipping stuff or some of you don't. So just pay attention what I'm underlining and things like that, okay? So if we have the equation 3x plus y equals 7, the point 2, is a solution point of the equation because the equation satisfies or is true when 2 is substituted in for x and 1 is substituted in for y. So if I plugged in a 2, I get 6 plus 1 equals 7. Yes? What if I plugged in 1? What would y have to be? If I plugged in x is 1, what would y have to be? 4. So are there multiple solution sets? Yes. 0 and 7. So to find a solution, to find other solutions symmetrically, solve for the origin of the equation of y. And so then we would solve it for y. So y equals 7 minus 3x or negative 3x plus 7. So we would have the y-intercept at 7, and our slope would be down 3 and over 1, and then down 3 over 1, and it would be up 3 over 1, up 3 over 1, and so this would be kind of your axis of symmetry because it would extend from there, right? Okay. So if I ask you to make a table, this is what your table would look like, right? You'd plug in x's, get out y's. Okay. We could also use our calculators to do that. Remember, if we solve this for y, I touched it without turning on the pen.
I thought you got that.
I did. Savannah and I spent the whole last class period trying to get it to figure out, and it's off. It's still off, so I'm going to have to do some more messing. It's all right here. When I write, it writes to the side. So, okay, so if I solve this for y, I would have y equals, again, negative 3x plus 7. I could put that in my calculator and make a table also. Yes? Okay. There is an infinite number of solutions because there is no limit on that domain. It's a linear function. Okay, this is the graph, what it looks like. You know all this stuff. That's why this is a preview. Okay? So you probably won't have a whole lot of notes. Sketch the graph of x squared minus 2. Okay? So you first construct a table. So I picked an x, got out a y, picked an x, got out a y. Right? Okay, then what would I do after that? Just plot the points, right? I could start at the vertex and move out, because that's what's going to happen, right? Isn't it? Okay. So there's what my graph would look like. We have done all this stuff. We're just reviewing that we need to be able to do it. Okay. Our graph is here. Our vertex, if we look at this, we have x squared minus 2. Should we know this minus 2 is a k? It brought it down 2?
Yes.
Yes. And we know that x squared normally starts at 0 and goes up 1 over 1 up 1. Well, up 1 over whatever. So if I brought it down, 1 squared is 1, subtract 2 gives you negative 1. 2 squared is 4, subtract 2 is 2, so you get 2. So it just goes from there. Now again, we're sketching, not plotting, so as long as you had those 2 points, you would be able to just to sketch the rest of the graph. Okay, using a graphing utility to graph an equation in this case, so I want you to take your calculators real quick. Okay, that's fine. If you have it in my home, that's fine, but just make sure you know where it's at.
Oh, it's, yeah.
Like,
Oh my God.
Okay, in order to graph on your calculators, it always has to be y equals first, correct? So make sure it's y equals, which all of these are. You guys are doing A. We should do different ones.
I'll do B.
Okay, who's doing C? D?
I'll do D.
Who's doing A?
Me.
Okay. Really messed up my. Okay, so some things you need to look at. Is it symmetrical?
No.
Does it have turns?
Yes.
I typed mine in and it's not showing up on my thing.
What about your window?
Hit Zoom 6.
Yeah.
Especially when you're using those ones in class, you're going to have to, you know. Did it show up? Which one did you do?
D.
Hit Zoom and then fit.
Well, my thing's like frozen.
Oh, because you paused it. Hit enter again and don't touch anything. Over in the corner, it was going like this. You paused
Zoom, fit.
it. Yep.
There.
Got it now? Okay, is it symmetrical? Who has a symmetrical graph? What does symmetrical mean?
Same on both sides.
Same on both sides. Because it could be symmetrical about the x or the y or the origin, like that one line was the origin, right? Okay, nobody has a symmetrical graph?
No.
Okay. Can anybody tell me why? What's your power? What's the degree of those?
X cubed.
Cubed is the degree. It wouldn't be x, but cubed. So are cubed graphs symmetric?
Nope.
No, because they're not, right? So they're not symmetric. They could be symmetric about the origin, but not typically. So with your graph, your calculator can give you an insight when you're struggling. Okay, so intercepts on a graph. Intercepts are where it crosses what? The x and the y axis. There's a lot of words on there. Okay, so what you need to remember are intercepts are where it crosses the x. You have x-intercepts and you have y-intercepts. Every x-intercept, what is the y? 0. Every y-intercept, what is the x? 0. Are we good? Okay. I guess if I leave all those words, it will teach you guys how to pick out the important stuff, which actually would be very beneficial, I guess. Okay, so it is possible for a graph to have no intercepts, or it might have several. If it is a function, it will only have one y-intercept. Okay? At most, it can only have one y-intercept if it is a function. Because functions, remember, you have to pass that vertical line test. So the y-intercept would be. Okay, now the first one has no x-intercept but a y-intercept. The second one has x and y intercepts. The third one has one x intercept, but two y intercepts. And then the fourth one has none. Now, which ones of those are not functions? 1, 2, 3, or 4?
3 and 4.
3 and 4 are not functions, are they? Not on their entire domain. We could maybe limit it and see what we could do. I guess on number 3, you'd actually have to limit your range, wouldn't you? Because it would be your y values that would cause the issues. So, both of them, you'd have to limit y values, sure. Right there, yeah. Okay, am I good? Nope. Okay. So a calculator could tell you that, right? If it asks how many intercepts, a calculator definitely would be good for that, wouldn't it? Okay. Okay, find the x and y intercepts of the graph y equals x cubed minus 4x. So I'm going to find the x int, and we're going to label it just with x int. What is the y every time on the x-intercept? 0. So I'm already going to put a 0 in there. And then I'm going to plug 0. So I have 0 equals, what do I have to do with x cubed minus 4x to solve it? I have to, it's one of our F words, factor. So I factor out an x, yes. And I have x squared minus 4. Well, do I got to factor again?
Yeah.
So x and x minus 2 and x plus 2. So we have 3 x-intercepts, don't we? What's x? We have 0, positive 2, and negative 2. So I have 0, 0, negative 2, 0, and 2, 0. So how do we find a y-intercept? 0 for x, right? So we would have y equals, well, 0 cubed would be what? 0. Minus 4 times 0, which would be? 0. So the whole thing is 0. Okay, now, if I have an x-intercept at 0, 0, do I have to have a y-intercept at 0, 0?
Yes.
Yes. So if we didn't find it was 0, 0, we did something wrong, correct? Or if we found the y was 0, 0 and the x didn't have it, something went wrong. Am I good? Okay, so I could graph it from there, couldn't I? My equation was, did anybody write it up? Wasn't it y equaled x cubed minus 4x? Yes? So I know it's odd, correct? I know it's odd positive, don't I? So that starts down and ends up. I knew my x-intercepts were 0, or negative 2, 0, and 2. So negative 2, 0, and 2. I knew my y-intercept was 0 also. Should I be able to sketch something fairly well? Yes. Now, last year when we would do these, I'd say, oh, we don't know how far it goes up or down. That's for calculus. That is for calculus. Not today, but that is for calculus. We will find this point right here. And we will find that point right there. Okay?
Wait, how do we know to start down?
Because it's odd. Odd always start and end at the
What's
different
odd?
places. The degree.
Oh.
Remember?
Yeah.
They start, and since it's positive, it's going to end up, so that means it had to start down. Am I good? Okay, symmetry tests. Okay, knowing that, there's nothing right here. Okay, knowing the symmetry of a graph before attempting to sketch it is useful because only half as many points are needed to sketch the graph. So if I know it's symmetrical about the x-axis, I can do positive x or positive y values and then just copy it to the negative, right? I can do that. If I know it's symmetrical about the y, I can do the same thing. If I know it's symmetrical about the origin, if it's in the second quadrant, I can reflect it to the fourth quadrant. So actually, I got to go backwards. Second for you, fourth. So it helps. Okay, so we need to know those types. So this is a y-axis symmetry. Because why? What's the line of symmetry? The y-axis. Okay, so this is symmetric respect to the y-axis. This would be your example. And respect means that that's your line of symmetry, that everything is copied. Doesn't have to be like, no. Symmetric with respect to the y-axis and at least a little picture. You're right by my door. Are you good?
You know.
No?
Yes.
Jaden?
Yeah.
No detail, guys. No detail. Okay. This is symmetric with respects to what? The x. And now you can see, like, if you found the top part, you could just go with the sound effects, of course.
No. That looks so weird.
It does. But they're trying, I think they're trying to show you something that wouldn't associate with something else. Does that make sense? I would probably draw something like that. Is that for the y-axis?
That looks more normal.
Right. And I think that's what they're trying to do, is avoid something that you identify with. Maybe. I don't know. Are we good? Oh, actually, let me go back 1 second. I wanted to point out, and I forgot to, this is negative x, y, and this is positive x, y. So the y's are exactly the same, that the x's are negative, yes? So on the next one, the x's are going to be the same, and what's negative? The y's. So if that's something you need to add, you can. Okay, so now with respect to the origin. We've done all the symmetry in geometry, and you thought I was crazy why we were doing it, and we had all those rules, right? Well, when we were respect to the y, we said negative xy. When we respect to the x, we said negative y, or x, negative y. Well, when we do origin, we do negative x, negative y. So both of them change. And those are the rules to do it. I don't know if you would, if I write them like this, will you guys remember? Remember doing this? When we did our symmetry ones?
Mm-hmm.
Yeah. You went back, oop, I forgot my arrow. You'd have that little arrow there. If you go back to your geometry composition notebook. Anybody still have theirs?
Well,
Your geometry
somewhere.
composition notebook?
Yeah, somewhere.
Ainsley, were you here in geometry?
Yeah, I had to retake it because I failed
Oh,
my
that's-
freshman year.
That's right.
Second semester, anyway. I actually kind of gave up my freshman year because there was like a semester delay.
I give up every year.
Okay, am I good? No. Jade, let me know when I'm good.
We're good.
Okay. Okay, test for symmetry. These are the tests. You need to know this. Okay? A graph of an equation x and y is symmetric with respect to the x and y if replacing x by negative x gives you an equivalent equation. So if you take the x and put a negative x in, you get back what you started with. Okay? That is the y-axis. The x-axis, you replace the y with negative y, and when you simplify, you get what you started with. This right here, this equivalent equation, is what you started with. Does that make sense what I'm saying to you? Okay. And for the origin, guess what? You replace both. You will need to test for symmetry. So when something asks, because could I be symmetric to the x and the y-axis?
Yes.
Yeah, I could. Like if it was a circle right on the origin, would that be both? Yeah. So I don't only check for one, I have to check for actually all three. Because a circle would actually be the origin as well, wouldn't it? Only if the center was at the origin. If the center wasn't at the origin, it wouldn't be. So.
Well, what if I just do them?
What?
Well, I just have this last sentence.
Jaden, we're absolutely fine.
And I can also read it off of my paper.
If we end up having somebody who's slow at note taking, maybe they will have to finish notes at home. If we get to that point. But we're not at that point yet. Are we good?
Yeah.
Okay, the graph of the polynomial structure of the y-axis in each of the terms of, for instance, okay. Okay, test the graph of y equals 2x cubed minus x with respect to the y-axis and the origin. I don't know why I didn't say x-axis. I don't know why. Okay, so y-axis, what did we need to change? The x. Okay, so I always just put y-axis. So then I have y equals 2 times negative x cubed minus negative x. Because that's what it told me to do, right?
Yes.
Okay, so when I cube a negative x, I'm still going to get a what? Negative x?
Yeah.
So it'd be negative 2x cubed plus x. Okay, did I get what I started with? Is this that?
No.
No. So is it symmetric? No. Okay.
Whoa, what?
Okay, So now I have the origin. So what do I do for origin?
You place both the x and
Okay.
y.
So a negative y equals, now I already know that the negative x is going to equal this over here. Yes? So I can just use it, or do you want me to do the whole thing? Do the whole thing. Okay, so 2 negative x cubed minus negative x, right?
Yes.
Okay, so that gives me negative 2x cubed plus x equals negative y. Well, you can't leave a negative y, right? So you have to multiply everything by a negative. So that would give me y equals 2x cubed minus x. Did I get what I started? Did it? Yes. So it is symmetric where?
Origin.
Yep. And we say about the origin. Or you can, I say about the origin. Some people say with respect to the origin. I have heard people say over the origin. That sounds really weird to me.
So you don't want us to say symmetric in the origin?
No, it is definitely not, it has to be about or respect to, but it can't be in. Like it's not.
I know it's not in, but I just...
Right. I have heard people say over, and I would just, right now, I would definitely caution you against saying over because no book will ever say that. And you want to know what the textbook is talking about when they're talking about it. So is that pretty basic? You know those rules, right? So those symmetric tests, you need to box, you need to something, because you will use those. Replacing the x and the y. Okay. And see, they put symmetric with respect to the origin. And we said about the origin. So it's the same sentence. Make sense?
Yep.
Okay. There's the picture of the graph. So can you see that that is symmetrical if I took this piece, right here and flipped it over the origin, would I get this piece right here?
Yes.
Yes. That is the one. It is so easy to see x and y. It is so easy to see x and y. Origin is kind of iffy sometimes, especially if the graphs, like if I cut off, because our brains, I mean, you've been taught never to trust a picture, right? So like if I cut this graph like this,
Whoa. I didn't know you could do that.
yeah, I'm just coloring over it with white. If I do that to that graph, does your brain say reflected over the, like it's
No.
symmetric? No, because it's not drawn exactly the same on both. So those algebraic tests are really important. Okay? Because we've been taught never trust a picture. We learned that in geometry, right? Because we all know how wonderful of artists we are, huh? Okay, we are going to stop for the day. Your assignment is not, like, we didn't cover everything in your assignment, but you're like intercepts. Have we covered intercepts in your worksheets that we've done? Yes. So every concept on this assignment you have been taught before. There is absolutely nothing new. So if you keep going and can only do here and there and whatever, do what you can, okay?
Are there questions